Welcome to Still Science Lab. Tonight, we explore about what actually determines the speed of light. We begin our journey with a profound paradox of scale, an architectural mystery that underpins every corner of the observable cosmos and quietly shatters our most fundamental assumptions about cause, effect, and the nature of motion. Consider a modest candle flame flickering quietly on a table in your kitchen. It is a simple, domestic event, driven by a familiar chemical reaction where hydrocarbon molecules bind with oxygen at a temperature of perhaps 1500 degrees. This flame produces light, casting a gentle, warm glow across the walls of the room. Now, cast your mind outward, past the protective blanket of our atmosphere, past the familiar boundaries of our solar system, and out into the crushing, silent void of deep space. Look toward a distant quasar burning furiously at the very edge of the observable universe. This celestial engine, powered by a supermassive black hole consuming entire solar systems, unleashes a torrent of radiation so bright it outshines 100 galaxies combined. Or consider a gamma ray burst from a collapsing star, a cataclysmic stellar eruption that unleashes more raw, violent energy in a few fleeting seconds than our sun will release over its entire 10 billion-year lifetime. These phenomena exist at entirely unbridgeable extremes of reality. The reactants are different, the temperatures are separated by factors of trillions, and the physical mechanisms could not be more distinct from one another. Yet, the moment each of these radically different processes produces a photon, something extraordinary happens. Every single one of these photons, the calm ones emerging from the candle, the violent ones born from cosmic cataclysms, the ones so faint they can barely be registered by our most sensitive instruments, and the ones so intensely energetic they could instantly shatter atomic nuclei, travels at exactly the same speed through empty space. Not approximately the same speed, not statistically similar, but exactly the same speed, down to as many decimal places as any experiment has ever probed. The photon that just left the flickering candle beside you is racing forward at the exact same velocity as the photon that has been streaking across the silent, expanding cosmos for over 13 billion years. Nothing pushes these particles. Nothing accelerates them, nothing retards them, and nothing gives them an extra nudge of momentum. They are never slow, they are never fast. They know only this one, invariant speed. In a vacuum, they all move at the same speed, without exception. There are no fast photons, there are no slow photons. There are only photons moving. To appreciate just how deeply this fact subverts our understanding of nature, we must look at how nearly everything else in our everyday world behaves. From the moment we open our eyes as infants, our brains construct an internal map of physics based entirely on effort and consequence. If you throw a baseball, its speed is directly, inextricably tied to how hard you throw it. A casual toss yields a slow, looping arc. A determined, powerful pitch drives the ball forward at 90 miles per hour. Fire a bullet from different rifles, and the muzzle velocity varies dramatically depending on the length of the barrel, the design of the weapon, and the chemical composition of the gunpowder exploding behind the projectile. Push a stalled car from rest, and its speed climbs gradually, inch by inch, foot by foot, as your muscles perform work and transfer kinetic energy to the frame. Kick a soccer ball softly, and it drifts lazily across the grass. Kick it with everything you have, and it rockets into the back of the net. In the mechanics of the macroscopic world, speed is always a downstream property of how an object was set into motion. Different launches inevitably yield different speeds. This is the absolute, unbroken rule of our daily reality. It is a logic built on proportionality. More force means more speed. Less force means less speed. We expect a direct, measurable inheritance between the violence of the cause and the velocity of the effect. Light, however, completely refuses to participate in this universal contract. The source of a photon determines a great many things about that particle, but speed is entirely removed from the ledger of the source's control. Nature has decoupled these properties in a way that it has never done for anything else in existence. When an atom, a lamp, a laser, or a star produces a photon, that production event fixes a rich set of properties. The first thing the source controls is the photon's energy. Every photon carries a specific amount of energy, set by how it was made. An electron falling from a high energy level to a lower energy level in a hydrogen atom will release a photon whose energy exactly equals the difference between those two levels. Whatever that difference happens to be, that is the exact amount of energy the photon will carry into the void. A different atom or a different transition will yield a completely different amount of energy. A microwave oven produces photons of very low energy because the alternating current oscillating inside its magnetron makes photons with long wavelengths. A medical X-ray machine produces photons of enormous energy because high-speed electrons crashing into a metal target create photons with incredibly short wavelengths. Closely tied to this energy is frequency. Every photon oscillates at a specific rate, a specific number of cycles per second, because photon energy is directly tied to frequency. Fixing the energy automatically fixes how fast the wave oscillates. A gamma-ray photon might oscillate 100 billion times a second, while a radio photon might oscillate only a few thousand times per second. This frequency, in turn, determines the wavelength, which is simply how far the wave travels in one complete oscillation. So the source controls energy, frequency, and wavelength. These are all bundled together, and they can vary enormously across the full electromagnetic spectrum, spanning a range of energies that covers more than 20 orders of magnitude. If a low-energy photon and a high-energy photon were compared as if they were animals, we would be comparing something smaller than a virus to something larger than a whale. The differences are almost absurd, and yet they all move at the exact same speed. The source also determines the direction of the photon, imprinting it with its initial trajectory, and it shapes the polarization, determining how the electric and magnetic components of the wave are oriented. Energy, frequency, wavelength, direction, and polarization. This is a rich set of properties, essentially everything a physicist would think to specify about a wave. And still, the source does not control the vacuum speed of the photon. That speed is fixed for every photon that has ever existed and every photon that ever will exist. This is where most human intuition experiences a total breakdown. The natural, almost inescapable response is to think that a photon with more energy must somehow move faster. A gamma-ray photon carries trillions of times more energy than a radio photon. Surely, if we hand nature a more energetic particle, it should also move that particle more quickly. Every other massive object in the universe obeys that intuition. Give a rocket more thrust, and it accelerates. Give a runner more energy, and they can sprint faster than they can jog. Why would a high-energy photon not simply be a faster photon? The answer is that photons do not use their energy to determine their speed. Their energy determines their frequency, their color, and how they interact with matter, but it never translates into velocity. Speed and energy are completely decoupled. Physicists have tested this independence over and over again. Experiments have compared the arrival times of gamma rays and visible light from the same distant cosmic events, such as supernovas, quasars, and gamma-ray bursts billions of light-years away. The reasoning is simple. If higher-energy photons traveled even slightly faster than lower-energy photons, even by 1 part in a trillion, the extra energy would show up as an earlier arrival after a long enough journey. Any tiny difference would accumulate over billions of years of travel into an obvious, measurable delay. Astronomers looked for this delay with painstaking care, examining the highest energy photons ever detected. No delay was found. Whether they carry almost no energy at all or carry trillions of times more, they arrive together, having traveled at the identical speed for the same vast duration of time. There is a second, equally stubborn intuition that must be cleared away before any of this can start to make sense. It is the intuition that light must begin at rest and then accelerate up to its speed. When a bullet leaves a gun, it begins at rest inside the barrel and accelerates as the gases expand behind it. A ball dropped from a rooftop begins at rest and accelerates under gravity, its speed climbing steadily as it falls. Almost every moving object we know follows this pattern of an initial state of rest, followed by acceleration, followed by a final velocity. It feels natural to imagine that light must be the same way. That first the photon exists sitting still, then some atomic process pushes it, giving it a shove, and eventually it speeds up to the enormous velocity at which we always observe it moving. But that picture is wrong from the very first moment. A photon is never at rest, not once, not for the shortest sliver of time. There is no phase of a photon's existence during which it sits still. The instant a photon comes into being, the instant an electron drops between energy levels or a nuclear reaction completes, the photon is already moving at the full vacuum speed of light. There is no ramp-up, there is no acceleration, and there is no transitional stage. 0 to full speed happens in 0 time because there is no 0 state to accelerate away from. This is not just a strange fact to be memorized. It is a direct consequence of what a photon actually is at the deepest level. In the physics of relativity, the difference between things that can sit still and things that must always move comes down to a single property: rest mass. Anything with rest mass has a reference frame in which it can be observed sitting perfectly still. A baseball can sit on a bench, an electron can be trapped in an electric field, and a ball of gas can drift at low speed through space. All of these have rest mass, and all of them have rest frames. A photon has no rest mass. Because it is entirely massless, there is no reference frame in which a photon sits still. You cannot chase a photon and catch up to it. You cannot slow it down to a stop by running alongside it, and you cannot even slow it down by a hair. In every frame of reference, from every possible perspective, the photon moves at the exact same speed. It lives permanently on what physicists call the light cone, a geometric structure inside the mathematics of relativity that separates the possible speeds of massive things from the single speed that massless things are required to travel. Speed is simply not a property that can be varied for a photon. Every photon has the same speed, full stop. This is why the paradox is a real, haunting paradox. If the source of a photon does not determine its speed, if the energy of a photon does not determine its speed, and if the photon does not accelerate up to its speed from rest, then where does the speed actually come from? What sets it? What determines that this specific number, and not some other number, is the value that every single photon in the universe must obey? The answer, when it finally comes into focus, is that the speed is not set by anything about the photon at all. It is not set by the source, it is not set by the emission process, and it is not set by any mechanical pushing. The speed is set by something much deeper, by the underlying fields that fill the universe, and by the geometric structure of space and time itself. The photon simply obeys what the universe demands of it. As we stand on the threshold of this realization, we are forced to experience a quiet, creeping sensation of wonder. The absolute invariance of this speed suggests that we are not looking at a mere quirk of a particle, but at a fundamental law of the theater we inhabit. The universe has decided that there is exactly one speed at which certain kinds of things must move, a cosmic boundary line that remains completely indifferent to the details of the objects themselves. The details of the source drop out, the energy drops out, and the wavelength drops out, leaving only a single, unbending number stamped into the very foundation of reality. This constant acts as an absolute anchor in a world of fluid, shifting perspectives. It whispers to us that reality is not a chaotic accident of random forces, but a deeply structured, geometric tapestry where even the most violent events must answer to a quiet, universal constraint. We are looking at a cosmic rule that does not care about the history of the particle or the violence of its creation. It is an unyielding architectural mandate, a number written into the very fabric of existence, waiting quietly for us to look past the surface of the things we can touch and finally ask what holds the entire system together. To truly comprehend the deep, architectural mystery of light, we must first examine the boundaries of influence within the physical world. When an event occurs in the universe to produce a photon, it seems to act with absolute authority over its creation. The source meticulously sculpts the identity of the particle, acting as an author dictating the precise terms of its existence. Consider the fundamental mechanics of emission. When a solitary hydrogen atom, drifting in the silent depths of an interstellar cloud, releases a photon, it does so through a delicate and precise quantum transaction. An electron, suspended in a high state of excitation, inevitably falls to a lower, more stable energy level, and in doing so, it releases a tiny sliver of radiation. The photon that emerges from this microscopic descent carries a very specific amount of energy, and that exact amount is dictated entirely by the gap between those two quantum levels. Whatever that mathematical difference happens to be, that is the strict energy burden the photon will carry out into the void. A different atom, undergoing a different quantum transition, will yield an entirely different amount of energy. The source is the undisputed architect of this power. We see this absolute control replicated across every piece of technology and every celestial body we observe. A microwave oven sitting in a kitchen produces photons of distinctly low energy. This happens because the specific process that generates them, an alternating current rapidly oscillating inside a magnetron, naturally creates photons with long wavelengths measuring several centimeters. On the opposite end of the human spectrum, a medical X-ray machine produces photons of terrifyingly enormous energy. It achieves this because the physical mechanism driving it, high-speed electrons being violently crashed into a dense metal target, creates photons with wavelengths thousands of times shorter than the width of a single hydrogen atom. The environment of birth completely, irreversibly dictates the energy of the offspring. Closely tethered to this transfer of energy is the fundamental property of frequency. Every photon oscillates at a specific rate, completing a precise number of geometric cycles every single second, a rhythm measured in hertz. The relationship between a photon's energy and its frequency is one of the most famous and immutable laws in all of physics, an equation first written down by Max Planck in the year 1900 and elegantly extended by Albert Einstein in 1905. This fundamental law dictates that fixing the energy of a photon automatically and permanently fixes its frequency. High-energy photons vibrate with frantic, aggressive intensity, oscillating at extraordinarily high frequencies. Conversely, low-energy photons oscillate with a slow, sweeping rhythm at very low frequencies. A violent gamma-ray photon might oscillate an unfathomable 10 to the 20th times per second, which translates to 100 billion times a single second. A calm radio photon, born from a gentle emission, might oscillate only a few thousand times per second. This frequency, in turn, strictly and geometrically determines the wavelength, because the wavelength is simply the physical distance the wave travels to complete one full oscillation. So, the source ultimately controls the energy, the frequency, and the wavelength. These three traits are bundled together in an unbreakable mathematical package. Set one of them, and you have instantly set the others. The authority of the source extends even further into the physical behavior of the light. The source determines the initial direction of the photon's journey. If a laser is precisely pointed toward the east, the photon exits the device heading east. If a bare bulb is glowing in the center of a dark room, photons are cast outward in every possible direction simultaneously. In the case of a single, isolated atom, there is an inherent element of quantum randomness involved, meaning the atom does not deterministically pick one specific, guaranteed direction. But when the photon is finally measured, it is always found to have gone somewhere, and the probabilities of those different directional paths are firmly set by the atom's local environment and its physical orientation. Either way, the source is the exact location where this vital directional information is permanently imprinted on the light. Once the photon is out and traveling freely through empty space, its direction is locked until something physically interferes with its path. Finally, there is the intricate property of polarization. A photon can be polarized in distinct ways depending entirely on how the electric and magnetic components of its wave are geometrically oriented. Some sources in the universe produce polarized light naturally. Sunlight reflecting off the flat surface of a body of water becomes partially polarized through the physical interaction of the bounce. The piercing light emitted from a laser is highly polarized, simply because of how the internal lasing process fundamentally works. In contrast, the light spilling from a standard fluorescent bulb is largely unpolarized, a chaotic mixture of orientations, because the countless millions of individual atoms emitting the light are not communicating or coordinating with one another. The source, once again, shapes the polarization. Energy, frequency, wavelength, direction, and polarization. This is a remarkably rich, deeply detailed set of properties. It represents essentially everything a theoretical physicist would ever think to specify about a wave. The source meticulously sculpts the identity of the photon, giving it a unique, complex fingerprint that distinguishes it from the trillions of other photons racing through the darkness. And yet, despite this sweeping, comprehensive control over the photon's physical nature, the source is utterly powerless to dictate the one property that governs the photon's movement through space. Still, the source does not control the vacuum speed of the photon. That speed is fixed. It is fixed for every single photon that has ever existed in the deep history of the cosmos, and it remains fixed for every photon that ever will exist. This is precisely where most people's intuition begins to aggressively break down. The natural, almost inescapable human response is to assume that a photon carrying more energy must somehow move faster. It is an assumption born from a lifetime of interacting with mass and momentum. A gamma-ray photon carries trillions of times more energy than a simple radio photon. Surely, the logical mind insists, if we hand nature a vastly more energetic particle, nature should also move that particle more quickly. Every other massive object in the universe obeys that exact intuition. Give a car more fuel and let its engine burn harder, and it goes faster. Give a rocket more thrust, and it violently accelerates. Give a human runner more energy, and they can sprint much faster than they can jog. Why would a high-energy photon not simply be a faster photon? The answer is that photons do not use their energy to determine their speed. Their energy determines their frequency. It determines their color in the broadest, most expansive sense of that word, placing them precisely where they belong on the electromagnetic spectrum. It determines exactly what kinds of interactions they are allowed to have with matter. Whether they can violently knock an electron out of an atom, whether they can pass seamlessly through the dense tissues of the human body, whether they can be seen by the biological mechanics of the eye, or whether they can be felt merely as a ghost of heat on the skin. Energy defines all of this. But energy does not translate into speed for a photon. Speed is fixed. Energy varies. These two fundamental properties of light are completely decoupled from one another in a way that they are not decoupled for anything else in the known universe. To truly grasp the staggering weight of this decoupling, we must confront the absurd, almost incomprehensible scale of the electromagnetic spectrum. The variations in energy that a source can impart to a photon span an expanse of more than 20 orders of magnitude. That is a mathematical factor of 100 billion. Human intuition completely fails at this immense scale, so we must rely on physical analogies to feel the weight of this difference. Imagine, for a moment, trying to compare a low-energy radio photon to a high-energy gamma-ray photon. If we were to scale these two invisible entities up and compare them as if they were living animals sharing the same ecosystem, we would not be comparing a mouse to an elephant. We would be comparing something smaller than a microscopic virus to something larger than a massive blue whale. The physical differences between these two extremes are almost absurd. The gamma ray is a microscopic buzzsaw, carrying enough concentrated power to rip apart the DNA in your cells and shatter the bonds holding an atomic nucleus together. The radio wave is a sprawling, gentle giant, passing harmlessly through the walls of your home without leaving a trace. One is a product of the most violent, catastrophic forces in the universe. The other is the whisper of cold, drifting gas. They do not look alike. They do not behave alike, and they interact with the physical world in fundamentally different ways. And yet, despite these absurd physical discrepancies, they all move at the exact same speed. The virus and the whale are racing side by side through the vacuum of space, perfectly matched forever. The immense, crushing difference in their energy does absolutely nothing to alter their velocity. But modern science is not built on intuition or striking metaphors. It is built on rigorous, unforgiving measurement. Physicists have tested this decoupling of energy and speed over and over again, continually pushing the limits of our observational technology. In the 20th century, and with increasing precision into the 21st, scientists turned their gaze away from terrestrial laboratories and looked toward the deepest, oldest reaches of the cosmos to test the laws of light. They set up experiments specifically designed to compare the arrival times of gamma rays and visible light originating from the exact same distant cosmic events. They pointed their instruments at supernovas tearing themselves apart, at ancient quasars blazing in the early universe, and at gamma-ray bursts exploding billions of light-years away. The reasoning behind these cosmic experiments is beautifully simple and incredibly powerful. If higher energy photons traveled even slightly faster than lower energy photons, even by a microscopic margin of 1 part in a trillion, that tiny extra energy would inevitably show up as an earlier arrival after a long enough journey. Over the distance of a laboratory room, the difference would be completely undetectable. Over the distance between the Earth and the Moon, it would be a fleeting shadow of a fraction of a second. But space is vast, and the light from a distant quasar has been traveling for billions of years. Imagine 2 photons, born in the exact same roaring instant of a dying star's collapse, thrown outward into the silent, freezing abyss of intergalactic space. Over a journey spanning cosmic voids and deep time, any microscopic speed advantage would endlessly compound. By the time the light finally reached the lenses of our orbital telescopes, any tiny difference would accumulate into an obvious, undeniable delay. The high-energy gamma rays would cross the finish line days, weeks, or even months before the lower-energy visible light from the exact same explosion. Astronomers searched the skies for this delay. They analyzed the highest energy photons ever detected from these distant cosmic sources, particles carrying up to an unfathomable trillions of electron volts of energy each, and they meticulously compared their arrival times against the sluggish, lower-energy photons emitted by the exact same cataclysm. The result they found was a testament to the absolute, silent precision of the universe. No delay was found. None. Whether scientists look at photons carrying almost no energy at all, or photons carrying trillions of times more raw power, they hit the detectors at the exact same moment. They arrive perfectly together, having traveled across the dark, silent expanse of the universe at the exact same speed for the exact same staggering amount of time. This cosmic proof forces us into a quiet, profound realization about the hierarchy of the universe. The things that create light, the chaotic, roaring fusion cores of stars, the delicate quantum dance of cold gas clouds, the violent collapse of dying suns, believe they are in absolute control. They stamp their signatures onto the photons they create, dictating their energy, charting their course, and defining their physical identity. But the moment those photons step off the edge of matter and enter the void, they are instantly stripped of their localized history. The universe itself takes over. The speed of the particle is no longer a conversation between the electron and the atom. It becomes a mandate enforced by the geometry of reality itself. We are forced to accept that we live in a cosmos where the violence of creation has a hard, absolute limit. The source can build the vessel. It can fill the sails with 1 trillion times more force, and it can point the compass toward the farthest edge of the galaxy, but it cannot dictate how fast the water flows beneath the hull. That speed is a rule older than the stars, written into the silent dark, reminding us that no matter how much energy a thing possesses, it remains perfectly, equally bound to the fundamental laws of the void. Our immersion in the physical world leaves us with a deep, almost unshakable psychological dependency on the concept of the transition. We live our lives surrounded by things that take time to happen, existing in a reality where change is a gradual, unfolding narrative. When we watch a bird launch itself from a tree branch, a sprinter explode out of the blocks, or a massive locomotive slowly pull away from a station platform, our eyes witness a smooth, continuous slope of velocity. Nothing in our macroscopic experience simply begins at its destination, and nothing leaps instantaneously into a state of rapid motion. We understand the world through a logic of development, a comforting physical architecture where speed is a mountain that must be climbed step by step, foot by foot, and mile by mile. This is the biological foundation of human intuition. We expect everything that moves to possess a history of acceleration, a transitional phase where it slowly overcomes its own stillness and builds momentum under the heavy, steady hand of a force. We can call this intuition the rule of the shove, and it governs our survival from the moment we are born. Think about the mechanical reality of a bullet being fired from a rifle. Inside the dark, metallic chamber of the weapon, the bullet begins its story in a state of absolute, unblinking stillness. It sits quietly in the dark, possessing zero velocity, completely inert. When the trigger is pulled, a firing pin strikes a primer, unleashing a sudden, violent chemical explosion. The gunpowder ignites, rapidly transforming into a pocket of superheated, high-pressure gas that expands with ferocious intensity. Yet, even under the weight of this immense chemical fury, the bullet does not instantly exit the muzzle at its terminal speed. It must build its velocity over a physical distance. The expanding gas must perform work on the metal projectile, pushing it continuously along the grooves of the rifled barrel, accelerating it through space and time over the length of the steel tube. Its final muzzle velocity is a direct consequence of this sustained, ongoing push. If the barrel is too short, the push is cut brief, and the bullet emerges sluggish. The motion requires a duration of time and a span of physical space to mature. We see this exact same narrative arc reflected when a heavy stone is dropped from the edge of a high rooftop. Before the stone is released, it rests motionless in a human hand, its speed locked firmly at zero. It possesses an immense reservoir of potential energy, a silent tension derived from its position within the Earth's gravitational field, but its actual kinetic movement is non-existent. The moment the hand opens and lets go, the stone does not instantly achieve a terrifying terminal velocity. Instead, it enters a state of graceful, linear acceleration. Gravity performs work on the mass of the stone, dragging it down toward the pavement below, adding a precise amount of speed with every passing microsecond. In the first foot of its fall, it moves relatively slowly. By the time it passes the third floor, it is rushing. And by the time it hits the Earth, it has accumulated a destructive momentum. The speed of the stone is a historical ledger of its journey through space, a downstream property of how long gravity was allowed to pull on its mass. This is the elegant, predictable clockwork of classical mechanics. It creates a comfortable world where motion has a clear beginning, a measurable middle, and an inevitable end. It allows our brains to calculate trajectories, predict collisions, and navigate the physical landscape with a sense of safety and control. But the moment we turn our attention away from the heavy, material objects of our daily lives and look toward the birth of light, this comfortable, classical clockwork breaks down completely. Light does not care about our biological addiction to transitions. It completely refuses to participate in the narrative arc of acceleration, committing a radical, almost violent act of defiance against the rule of the shove. When an event occurs anywhere in the cosmos to produce a photon, there is no preparatory phase, no mechanical runway, and no gradual buildup of speed. Consider what happens inside the blazing, high-pressure core of a star, or within the delicate electron shells of an atom sitting inside a lamp on your desk. An electron, suspended in a high, unstable energy state, experiences a sudden quantum leap, dropping instantly to a lower, more stable configuration. In that precise, infinitesimal fraction of a moment, a photon is born. The shocking reality of this birth is that the photon does not emerge from the atom in a state of rest. It does not look around the room, orient itself, and slowly step on an accelerator to gain momentum. There is no single sliver of time, no nanosecond, no picosecond, no femtosecond, during which the photon is traveling at half speed, struggling to shake off the stillness of its birth. At the exact, mathematically absolute instant of its creation, when time equals zero, the photon is already moving at the full, invariant vacuum speed of light. It goes from absolute non-existence to racing forward at nearly 300,000 kilometers per second in zero time. There is no ramp-up, there is no acceleration curve, and there is no transitional threshold. The photon is born moving, locked into its ultimate velocity from its very first breath, possessing the exact same speed at the moment of its emission as it will have after traveling across the dark intergalactic void for 13 billion years. To the human mind, this feels deeply unnatural, almost like a magic trick that violates the basic logic of cause and effect. How can a physical entity possess a velocity without ever crossing the intermediary steps required to reach that velocity? How can a thing be launched without an acceleration phase? The answer to this profound mystery is not found by searching for a hidden engine inside the photon, nor by imagining a cosmic hand that gives it an impossibly fast push. The answer requires us to dismantle our entire understanding of what mass is. Stepping into the radical landscape of Albert Einstein's relativity to examine the fundamental relationship between matter and the geometry of the universe. In the everyday language of human common sense, we tend to treat mass as a simple, straightforward concept. We think of it as weight, or solidity, or the physical volume of stuff that an object contains. We know that a boulder has more mass than a pebble because it is heavier to lift, harder to push, and causes more damage when it strikes an object. But relativity revealed that mass is something far more profound, far more beautiful, and entirely separate from our simple sensory definitions. Mass is an object's intrinsic relationship with the four-dimensional fabric of spacetime. Specifically, to understand why light is born at full speed, we must look at a property known to physicists as rest mass. Rest mass is the fundamental mass an object possesses when it is measured in a state of total, absolute immobility. The objects that populate our daily world, a baseball, a bullet, a drop of water, a planet, and even a tiny subatomic electron, all possess a non-zero rest mass. This property acts as a profound physical anchor, a mechanical tie that binds the object to a specific coordinate within the fabric of space and time. Because an object possesses rest mass, it is granted a unique and sacred privilege by the laws of physics. It has a rest frame. A rest frame is a specific point of view, a reference frame in the cosmos where the object can look at itself and declare, with absolute physical authority, that its velocity is zero. Because a baseball has rest mass, it can sit quietly on a wooden bench, occupying a single, stable address in the universe, completely motionless relative to the stadium around it. It can experience a state of rest because its mass anchors it to that location. This rest mass is also the exact reason why massive objects require time and energy to accelerate. Rest mass is the physical source of inertia. Inertia is nature's resistance to change, a stubborn mechanical desire of a massive object to maintain its current state of motion. If an object is sitting still, its rest mass demands that it remain sitting still. If it is moving, its rest mass demands that it maintain that exact velocity. To overcome this stubbornness, to break the anchor of inertia, an external force must perform physical work on the object over a duration of time. You must push the car, ignite the gunpowder behind the bullet, or throw the baseball with your arm. The acceleration phase is the literal, physical process of energy conquering mass, slowly dragging the object away from its rest frame and forcing its world line to bend through space and time. Because the object has a rest mass, it is heavy, it has inertia, and it is entirely bound to the slow, linear laws of acceleration. But a photon is not a baseball, and it is not an electron. A photon possesses absolutely, unconditionally zero rest mass. It is a pure, unadulterated excitation of the quantum field, entirely stripped of the material anchor that binds massive objects to a specific coordinate in space. And because it lacks this rest mass, the rules of the universe change completely. By denying the photon a rest mass, the laws of physics have stripped it of the very concept of inertia. It has no mechanical stubbornness, no resistance to change, and no anchor to hold it back. But this masslessness does not mean the photon is free to choose any speed it likes. It triggers a radical inversion of the laws of motion. Because a photon has zero rest mass, it is completely, permanently denied the privilege of a rest frame. There is no place in the entire expanse of the cosmos where a photon can sit still. It cannot hover in a laboratory, it cannot drift lazily through a cloud of gas, and it cannot even travel at a fraction of its velocity. The equations of relativity do not merely permit a massless entity to travel at the cosmic speed limit, they strictly and absolute require it. For a particle with zero rest mass, the invariant speed of light is not a distant goal to be reached through hard work, nor is it a maximum limit to be achieved by applying a massive force. It is the only speed that is mathematically permitted to exist. It is an existential mandate. A photon cannot travel slower than the speed of light for the exact same reason it cannot travel faster. The mathematics of space-time leave it with no other mode of existence. The instant it exists at all, it must exist at the invariant speed. To visualize this unyielding geometric requirement, physicists rely on a concept known as the light cone. The light cone is not a physical object made of matter, but a rigid, foundational structure written directly into the four-dimensional geometry of space-time. Imagine a single event occurring at a specific point in space and a specific moment in time. If that event emits a flash of light, that light expands outward in all directions as time moves forward, forming a growing sphere. In a four-dimensional diagram, where time is plotted vertically and space is plotted horizontally, this expanding sphere of light traces out a perfect, precise cone, the future light cone of that event. This geometric cone acts as the ultimate separator of destinies in our universe. The interior of the cone is what physicists call the time-like region. This is the domain of mass, every object that possesses a rest mass. Every human being, every planet, every stray electron is trapped forever inside the interior of this light cone. Their paths through the universe, their world lines, must always tilt more toward the vertical axis of time than the horizontal axis of space. They are heavy, they move slower than light, and they can never touch the edge of the cone, no matter how much energy they expend. But the photon does not live inside the cone. The photon lives permanently, immutably, on the very surface of the light cone itself. This surface is the null region of space-time, a geometric boundary where the distance traveled through space is perfectly, precisely balanced by the interval elapsed through time. A massless particle is not trapped inside the geometry. It is pinned to the boundary itself. It is the boundary. The instant a photon is born from an atomic transition, it does not have to travel from the inside of the cone to the edge. It is materialized directly onto the surface. It does not accelerate up to the light cone. It is a native inhabitant of the light cone's surface from the very first mathematical instant of its definition. There is no zero state to accelerate away from, because for a massless quantum, a state of rest is a mathematical impossibility, an invalid state that the geometry of the cosmos entirely forbids. This complete absence of an acceleration phase, this reality of being born at full speed, forces us into a profound and slightly unsettling existential reflection on the nature of light's experience of the universe. We live in a world where time and space feel like independent, solid realities. We measure our lives by the ticking of clocks and the crossing of distances, enduring the long, slow passage of hours as we travel from one physical coordinate to another. We experience space as an immense container and time as a relentless river carrying us forward. But because the photon is born at full speed, living its entire existence on the absolute boundary of the light cone, it experiences a reality that completely shatters these human definitions. According to the unyielding equations of relativity, as an object's velocity approaches the speed of light, the passage of time slows down relative to the outside world, a phenomenon known as time dilation. At the exact speed of light, the mathematics reach a radical threshold. Time dilation becomes infinite, because the photon travels precisely at this invariant speed from the moment of its birth. It does not experience the passage of time. Not a single tick of a clock, not a fraction of a second passes for a photon. From its own perspective, its birth, its journey across the universe, and its ultimate absorption by an atom happen in the exact same instantaneous flash. Simultaneously, relativity dictates that as an object moves faster, the distances along its path begin to shrink, a phenomenon known as length contraction. At the invariant speed of light, length contraction becomes absolute. Distance collapses to exactly zero. This means that to a photon, the universe has no depth, no width, and no vast interstellar voids. The 13 billion light-years of empty space that separate a distant, ancient galaxy from our planet do not exist from the perspective of the light itself. To the photon, the core of that ancient star and the retina of your eye are in direct, immediate contact. They are touching. The entire history of the cosmos, from the early moments of the Big Bang to the deep future of cold stars, is collapsed for light into a singular, timeless, and spaceless point of pure interaction. When you look up at the night sky and catch the faint, silver light of a star, you are participating in a relationship that bridges two completely irreconcilable realities. Your biological body, heavy with rest mass, anchored to a rest frame on Earth, has endured years of time and occupied a specific, isolated point in space to witness that moment. You feel the separation, you feel the distance, and you feel the slow, steady ticking of the clock. But the messenger that has arrived to deliver that star to your consciousness has experienced none of it. It was born at full speed, slipping seamlessly past the barriers of inertia, mass, and acceleration. It crossed the universe without ever aging a single microsecond, collapsing billions of light years into an instantaneous handshake between matter. We are left standing on the edge of a quiet, profound conceptual abyss. The photon reminds us that the rigid boundaries of our daily lives, the walls of distance that keep us separate, the passage of time that ages our frames, and the heavy inertia that makes movement an effort, are not the fundamental truth of the cosmos. They are merely the local rules imposed upon entities that carry the burden of mass. Beneath the heavy, classical surface of our world, there exists a native layer of reality that is completely unmoored from these constraints. It is a realm of pure, instantaneous potential, a timeless architecture where information does not need to build speed because it is already everywhere it needs to be, moving at the absolute limit of causality from the very first instant of its creation. We are heavy creatures looking out at a massless world, catching glimpses of an elegant, unyielding geometry that holds the entire system together from a place where time does not flow and distance has completely vanished into the dark. To understand where the speed of light actually comes from, we have to stop asking questions about particles. We must abandon the deeply ingrained intuition that a photon is a tiny, hard projectile, a miniature marble streaking through space, or a self-contained little traveler carrying its own hidden engine. The image of a localized bullet fired out of a cosmic lamp is a comfortable illusion born of our macroscopic habits, but it does not match the actual physics of reality, and it will never explain why every photon in the universe moves at the exact same speed. To answer that question, we must undergo a radical shift in our perception of existence. We must fundamentally discard the idea that the universe is built out of hard objects moving through a passive, empty void. Instead, we must look at the invisible architecture that dictates their movement. The universe is constructed from fields. A field is a concept that can sound mathematically abstract, yet it is deeply rooted in our daily intuition. It is simply the physicist's word for a quantity that possesses a value at every single point in space and at every single moment in time. Think of the ambient temperature in the room where you sit. Every precise location, from the cold corner of the ceiling to the warm floor beneath your chair, has a specific temperature value at any given second. Think of the wind sweeping across a vast, open landscape. Every point in the sky above a valley holds a specific wind velocity and a specific direction. A field is a rule that assigns a value, a number, or a direction to every location in space and time. And it turns out that these fields are not just mathematical conveniences. They are the primary substance of existence. Fields fill all of space, existing as fundamental entities even in the darkest, coldest regions of the cosmic void where absolutely nothing appears to be happening. The particles we believe we know so well, electrons, quarks, and photons, are not primary, independent objects. They are merely excitations of these underlying, ubiquitous fields. They are ripples, localized concentrations of energy in a medium that otherwise stretches quietly and invisibly across the entire cosmos. For light, the specific field in question is the electromagnetic field. Of all the invisible structures in nature, this one possesses the longest and most thoroughly documented history, simply because humanity has been able to measure, manipulate, and feel its effects since long before we truly understood what it was. The journey to understand this specific field began in the damp, dimly lit laboratories of 19th century London, during a time when physicists were slowly, painstakingly piecing together the mysterious connection between electricity and magnetism. In the 1830s, a brilliantly intuitive, self-taught experimenter named Michael Faraday was working with simple coils of wire and blocks of iron. Faraday possessed almost no formal mathematical training, yet he held one of the finest physical intuitions in the entire history of science. He had wound coils of copper wire around heavy iron rings, connecting some of those coils to crude chemical batteries and others to sensitive galvanometers. Delicate instruments designed to detect the absolute tiniest trickles of electrical current. He was searching for a bridge, a hidden link between the static spark of electricity and the silent, invisible pull of a magnet. What Faraday noticed in his quiet laboratory was something that simply should not have been possible according to the rigid, Newtonian physics of his day. When he closed the electrical switch, sending a sudden surge of current through the first copper coil, the needle of the galvanometer connected to the second, entirely separate coil twitched briefly, then immediately settled back to zero. When he opened the switch, cutting the power, the delicate needle twitched again, but this time in the exact opposite direction. The profoundly strange part was what happened in between those two moments. While the current in the first coil flowed powerfully and steadily, the galvanometer connected to the second coil read absolutely nothing. A steady, unchanging current in one coil produced no current in the other. Only the changes did. This deceptively simple observation was the seed of everything that followed, a profound crack in the classical understanding of the universe. Faraday had discovered that a changing magnetic field could induce an electric current in a nearby conductor, but only when it was in the active, ongoing process of changing. A static magnetic field, no matter how immensely strong, did absolutely nothing. Motion, change, and variation. Those were the physical acts that truly mattered. The universe cared about how things were changing, not just about how they passively existed. Electricity and magnetism were not separate, isolated forces of nature. They were intimately entangled, two distinct faces of the exact same underlying phenomenon. A changing magnetic field creates an electric field, and symmetrically, a changing electric field creates a magnetic field. Each one gives rise to the other whenever it fluctuates. To make sense of this invisible interaction, Faraday developed a visual concept that would forever alter human thought. He imagined invisible lines of magnetic force filling the empty space around a magnet, and similar lines of electric force filling the space around a charged object. When the magnetic field lines threading through a coil shifted or changed, whether because a physical magnet was moving or because the current in an adjacent wire was starting or stopping, an electric field instantly appeared in the coil, and that newly born electric field physically drove the current. These field lines were Faraday's profound way of making the invisible visible. They carried an implicit, revolutionary claim. The most interesting and fundamental physics was not happening inside the heavy copper wires or within the iron magnets. The true physics was happening in the empty space between them, out in the void where the fields themselves lived. This radical idea sat waiting for decades until James Clerk Maxwell, working in London in the 1860s, took Faraday's intuitive patterns and forged them into absolute mathematical precision. Maxwell possessed the formal mathematical machinery that Faraday lacked, and he used it to write down a set of 4 elegant equations. These equations, now known globally as Maxwell's equations, successfully captured everything that was known at the time about how electric and magnetic fields behave. But when Maxwell stared deeply into the architecture of his own mathematics, he noticed something extraordinary hiding within the symbols. The revelation was not immediately obvious. It fell out of the math only after he deliberately rearranged the equations to see what a self-sustaining electromagnetic disturbance would look like. When he wrote down the mathematical expression governing such a disturbance, it perfectly mirrored the form of a wave equation, a specific geometric relationship dictating how a wave varies in space and how it varies in time. The mathematics described a beautifully balanced, self-sustaining loop. As an electric field changes, it creates a magnetic field. As that new magnetic field changes, it immediately creates an electric field. The changes in one field are exactly what the other field needs to keep oscillating, and vice versa. This creates a ripple in the field that can propagate forward through completely empty space without needing anything physical to push it, because at every single instant, it is busy generating the very thing that will make it continue to exist. This perfectly synchronized dance of invisible forces is what we experience as light. But the most profound discovery lay buried within the speed of this mathematical wave. In Maxwell's wave equation, the speed of the ripple was determined by a specific mathematical combination of 2 completely independent constants. The first constant was the electric permittivity of vacuum, a specific number that describes exactly how strongly electric fields respond to electric charges. This number had been painstakingly measured by studying the physical forces between static charged objects in laboratory experiments that had absolutely nothing to do with light. The second constant was the magnetic permeability of vacuum, a number that dictates how strongly magnetic fields respond to electric currents. This, too, had been carefully measured by studying the physical forces between current-carrying wires in separate experiments completely unrelated to optics or illumination. These 2 numbers had been sitting quietly in physicists' notebooks for decades, each pinned down independently by careful, isolated benchtop measurements. Nobody had ever suspected that they had anything to do with each other, let alone with the grand cosmic phenomenon of light. But when Maxwell mathematically combined them in the specific way his wave equation demanded, dividing one by the other and taking the square root, he calculated a speed. And that resulting speed was, within the experimental uncertainty of the era, exactly the speed of light that had been separately measured by astronomers tracking the moons of Jupiter and by laboratory physicists timing light pulses across vast distances. 2 constants describing basic electricity and magnetism, measured with no reference to light whatsoever, combined flawlessly to produce the exact speed of light. This could not be a coincidence. It was one of the greatest moments of unification in the entire history of science. Maxwell had conclusively shown that light was an electromagnetic wave, and that the speed of light was fundamentally baked into the structural constants of the electromagnetic field itself. 2 apparently unrelated forces, electricity and magnetism, had been proven to be interconnected aspects of a single phenomenon, and that single phenomenon carried its own natural, inescapable wave speed. The profound beauty of this realization is that it instantly shatters the mechanical, particle-based paradox of light's velocity. If light were a bullet, its speed would depend on the gun that fired it. If light were a runner, its speed would depend on the energy in its muscles. But light is a wave in a field, and a wave does not choose its speed. To sharpen this intuition, imagine a long, tightly stretched string. If you pluck the string in the middle, a wave travels outward toward both ends. The speed at which that wave travels along the string is not chosen by you. You cannot pluck the string harder to make the wave move faster. You can pluck it harder to make the wave taller or louder, or to make it carry more energy. But the speed at which the physical disturbance travels horizontally along the string is set entirely by the string itself. It depends on the string's tension and the string's mass per unit length. Change those underlying properties, and you change the speed. But as long as the string remains what it is, the wave speed is what it is. You can make waves of any amplitude, any frequency, and any shape, and they will all stubbornly travel at the exact same speed along that string. The electromagnetic field operates in a deeply analogous way, though it is far more abstract. It has fundamental constants that describe its behavior. The electric permittivity of vacuum and the magnetic permeability of vacuum. These two constants play the role, roughly speaking, of the cosmic string's tension and mass. They set the rigid, unyielding speed at which any ripple in the field can propagate. Change absolutely nothing about the field, and every possible ripple, every single photon, is forced to travel at that specific speed. You cannot make a ripple travel faster by pumping more energy into it. You can make a taller wave, you can make a higher frequency wave, and you can make a shorter wavelength. But the speed is dictated by the field, and the field dictates one speed and one speed only. However, an important existential difference must not be glossed over in this analogy. A string is a real, material object. It has mass, it is made of atoms, and it has a physical, tactile extent. The electromagnetic field is nothing like that. The field is not made of tiny particles vibrating up and down. The field is not a physical fabric stretched across the sky like a canvas. The field does not have a preferred direction, it does not have a fixed reference frame, and it does not have a tangible substance to it. The field is the primary thing. It is not made out of anything more basic that we know about. It is one of the fundamental, foundational building blocks of physical reality. This is why the analogy with a string can only take us so far, and why the reality of light is so much more haunting. A wave on a string still needs a physical string to exist. A wave in the electromagnetic field does not need anything else. The field is the ground level of existence. And that means the speed of the wave, the speed of the photon, is not derivative of some more basic mechanical fact. It is derivative of the mathematical structure of the field itself, and the field is a fundamental property of the universe. This is the monumental realization that finally begins to loosen the grip of our initial paradox. The speed of light in a vacuum is not a property of the light source. It is not a property of the observer. It is an inherent property of the electromagnetic field. The constants of that field, those deep cosmic numbers that describe how strongly electric charges push and pull each other, and how strongly magnetic forces respond to changing currents, combine mathematically to dictate one specific value for the speed at which any disturbance can travel. That speed is fixed by the invisible architecture of the universe. Every photon obeys it simply because every photon is a ripple in that specific field. And every ripple in that field is physically required to move at that exact speed. When you look up at the night sky, you are not looking at a chaotic void filled with self-propelled particles. You are looking at a vast, silent ocean of invisible fields resting in their quiet ground states. When a star burns, it does not launch projectiles at us. It disturbs the field. It creates a localized oscillation, a perfectly balanced dance between electricity and magnetism that perfectly regenerates itself as it moves forward. The speed of that regeneration is locked into the mathematics of the void. If the speed of a photon comes from the architecture of the field, and the field is the same everywhere in the universe, then the speed must be the same everywhere in the universe. This is exactly what we observe. If the speed comes from the structure of the field, and the field does not care about what violent stellar process or gentle chemical reaction produced any particular ripple within it, then the speed does not depend on the source. This is exactly what we observe. If the speed comes from the structure of the field, and the field is not a mechanical substance made of anything that can be sped up or slowed down, then there is no way to give a photon a bigger push to make it faster. That, too, is exactly what we observe. We are no longer looking at a universe filled with speeding bullets. We are looking at a quiet, vibrating tapestry, where the rules of the fabric itself predetermine the movement of everything woven into it. The source merely plucks the string, but it is the invisible, underlying field that sings the note, carrying it across the dark expanse of the cosmos at the exact, unyielding speed that the mathematics of reality demand. The human mind is deeply and inescapably bound by the physical textures of the macroscopic world. We are creatures of matter, evolved to navigate a reality composed of tangible substances. When we drop a stone into a quiet pond, we watch the ripples push outward, and we understand intuitively that the wave is an action performed by the water. When we speak, our vocal cords compress the air, sending waves of pressure across the room to strike the eardrum of another person, and we understand that the sound is an action performed by the atmosphere. Every wave that humanity had ever encountered throughout its long history of observing nature was a wave in something. A wave was never an object in its own right. It was a physical disturbance in a physical medium. Water waves wave through water. Sound waves wave through air. Seismic waves wave through the crushing density of the Earth's crust. This mechanical intuition was so absolute, so universally verified by everyday experience, that it became an invisible trap for the greatest minds of the 19th century. When James Clerk Maxwell published his revolutionary equations, revealing that light was an electromagnetic wave, the scientific community celebrated the mathematical triumph, but they immediately imposed their material bias onto the discovery. The equations described a wave, and therefore, the strict logic of the era demanded that there must be a physical substance for the wave to ripple through. It seemed completely obvious that the electromagnetic wave we call light must be waving through something. The idea of a wave existing on its own, propagating through an absolute, empty nothingness, was philosophically abhorrent. It violated the mechanical clockwork of the Newtonian universe. And so, to protect their intuitive understanding of reality, physicists conjured a phantom. They filled the vast, silent void of the cosmos with an invisible, undetectable, all-pervading substance that they named the luminiferous ether. For decades, the ether was accepted not just as a theory, but as an unspoken, unquestionable necessity. Nobody could imagine a wave without something to wave in. The ether was hypothesized to be a medium unlike any other substance ever encountered. It had to be rigid enough to support the incredibly fast vibrations of high-frequency light. Yet it had to be perfectly frictionless so that planets and stars could glide through it for billions of years without slowly dragging to a halt. It was a contradictory, magical material, but its existence provided immense psychological comfort. If the ether existed, then light was fundamentally not so different from sound. It was just a mechanical disturbance in a medium, moving at a speed entirely determined by that medium's physical properties. More importantly, if the ether filled the entire universe, it provided a permanent, absolute stage for the cosmos. It would define a special, universal reference frame. Standing still relative to the ether would be objectively different from moving through it. It suggested that we could finally measure our absolute velocity through the universe. If you moved through this invisible ether in the exact same direction as a light beam, the laws of classical mechanics dictated that you should be able to catch up to the light a little bit. If you moved against the direction of the light, plowing head-on into the waves, you should meet the light a little faster. These were not just philosophical thought experiments. They were hard, testable predictions. The Earth is hurtling around the Sun at thousands of miles per hour, plunging through space. If the ether was real, the Earth was swimming through it, creating an ether wind that should push against the light passing through our laboratories. In 1887, two brilliant experimentalists, Albert Michelson and Edward Morley, set out to capture the ghost. They designed one of the most famous, elegant, and demanding experiments in the history of physics, an experiment specifically designed to detect the Earth's motion through the ether. To find something so elusive, they required an instrument of unprecedented, almost unimaginable sensitivity. The apparatus they built in Cleveland, Ohio, was a marvel of precision engineering. They knew that the faintest vibration from a passing horse-drawn carriage or the slight thermal expansion of a metal table could destroy their data. To isolate their instrument from the tremors of the world, they mounted it on a massive, heavy slab of stone. But they did not rest the stone on the floor. They placed the entire stone slab so that it floated effortlessly in a circular pool of liquid mercury. This ingenious liquid bearing allowed the heavy instrument to remain perfectly level while isolating it from ground vibrations, and crucially, it allowed the entire massive apparatus to be rotated smoothly and silently to any orientation with the gentlest push of a hand. The logic of their machine, an interferometer, was beautifully straightforward. A single, coherent beam of light entered the apparatus and struck a partially silvered mirror, which instantly split the light into two identical beams. These two beams were sent traveling at right angles to each other along the two perpendicular arms of the instrument. Each beam raced to the end of its respective arm, bounced off a highly polished, distant mirror, and returned along the exact same path to the partially silvered mirror where the two beams finally recombined into one. Where the two beams recombined, their electromagnetic waves overlapped, producing an interference pattern. This pattern appeared as a series of alternating light and dark fringes, and it depended exquisitely, sensitively on the exact difference in travel time between the two perpendicular paths. The reasoning behind the experiment was flawless classical physics. If light traveled through a stationary ether and the Earth was moving through that ether at high velocity, then the light going along the arm aligned with the Earth's motion should fight against the ether wind, taking a slightly different amount of time to complete its round trip compared to the light going along the perpendicular arm. This tiny discrepancy in time would physically shift the crests and troughs of the recombined light waves. The difference would show up visibly as a shift in the interference fringes. As Michelson and Morley slowly rotated the floating stone slab in the pool of mercury, the arm that was previously aligned with the Earth's motion would gradually become perpendicular to it, and the other arm would take its place. As the apparatus rotated, the interference shift should swing back and forth in a smooth, predictable pattern. Michelson had already calculated exactly how big this effect should be. Given the Earth's known orbital speed around the Sun, the fringe shift they were looking for should have been about 4/10 of a full fringe. It was a small deviation, certainly, but it was very much within the resolving power of his magnificent instrument. They began the hunt. They took thousands of measurements in the quiet isolation of their laboratory. They rotated the heavy apparatus in every possible direction. They repeated the experiment at different times of day, and they patiently waited to repeat it at different times of the year. knowing that as the seasons changed, the Earth would be moving in entirely different directions relative to any hypothetical universal ether. They looked for the fringe shift with agonizing, painstaking care, staring into the optics, waiting for the universe to reveal its hidden mechanical architecture. What they found shattered the foundations of physics. They found essentially nothing. The fringes did not shift. The light waves recombined with perfect, stubborn consistency. What tiny, microscopic variations they did see were completely random, entirely consistent with the baseline noise floor of the instrument itself. The predicted effect, the majestic 4/10 of a fringe shift that should have conclusively revealed the Earth's motion through the luminiferous ether, was completely absent. The silence of the data was deafening. It was one of the most spectacular, terrifying null results in the history of experimental physics. And it was so precise and so carefully reproduced that it could not be dismissed, ignored, or explained away as a mere mechanical error. The scientific community reacted with initial disbelief, followed by a desperate scramble to save the mechanical universe. Highly respected physicists at first refused to accept the null result, arguing vehemently that some subtle experimental flaw, some hidden thermal drift, must be responsible for masking the ether wind. But repeat after repeat produced the exact same outcome in laboratories on different continents, with progressively refined and even more sensitive instruments. When the experimental reality could no longer be denied, theoretical physicists tried valiantly to rescue the ether with increasingly bizarre mathematical contortions. Perhaps, some suggested, the ether was not stationary. Perhaps the Earth was dragging the local ether along with it as it moved, like a ship dragging a layer of water against its hull, so that in the immediate vicinity of the laboratory, there was simply no relative motion to detect. But this idea had massive, fatal problems of its own. It conflicted violently with astronomical observations of starlight, which shifted seasonally in a way that proved the Earth was moving independently through the cosmos, not sitting still inside a massive, co-moving bubble of dragged ether. When the dragging hypothesis failed, others proposed something even more radical. They suggested that objects moving through the ether were physically, literally contracted along their direction of motion, and that this physical shrinking happened in exactly the right mathematical proportion to perfectly cancel out the expected time delay in the interferometer. This contraction hypothesis, proposed by George Fitzgerald and later mathematically refined by Hendrik Lorentz, managed to temporarily save the ether, but only at the devastating cost of imposing a strange, ad hoc rule that objects mysteriously and conveniently shrank whenever they moved. But even this desperate rescue operation could not survive the deeper, cascading problems that were beginning to emerge across the landscape of physics as more and more experiments returned relentless negative results. The Michelson-Morley result was decisive in a way that shook physics to its absolute foundations. The apparatus had been sensitive enough to detect a fringe shift roughly 40 times smaller than what the ether hypothesis confidently predicted. And even that tiny, microscopic margin had shown up as nothing. The precision was overwhelming, and the message from the universe was unequivocal. By the turn of the century, the traditional, classical position had become impossible to hold. The ether, if it existed at all, could not be doing what everyone had assumed it must be doing. It could not be providing the material medium in which light waves propagate. It could not be defining a preferred, absolute rest frame in the universe. It could not be doing anything that could be detected, felt, or measured by any experiment ever devised by human hands. At that point, the only remaining logical conclusion was the one that physicists had spent decades desperately trying to avoid. The ether was not there. There was no invisible, frictionless medium filling the empty space of the cosmos. There was no material, mechanical substance that light was rippling through. The electromagnetic field was not a wave in something else. The electromagnetic field was the something. This is the exact threshold where the intuitive, comfortable picture of a mechanical wave has to be surrendered permanently, because it no longer describes what is really going on in reality. Water waves need water to exist. Sound waves need air to exist. But light waves do not need anything to wave in. The electromagnetic field is not a physical disturbance of some deeper, underlying substance. It is a fundamental feature of the universe in its own right, a primary entity present at every single point in space, whether or not anything is actively happening there. When nothing is happening, the field does not vanish. It sits quietly at its absolute ground state, resting in the dark. When something disturbs it, an accelerating electric charge, a violent nuclear reaction, or a delicate atomic transition, a ripple forms and propagates outward into the void. That ripple is exactly what we call light, and it moves through the emptiness of space because it is a brilliantly self-sustaining oscillation of the field itself, not because anything is mechanically pushing it. The photon is not being pushed by the vacuum. Nothing is doing work on the photon to keep it moving across the galaxy. The photon does not carry a hidden reserve of fuel that it slowly burns as it travels. There is no engine, there is no propulsion, and there is no invisible hand of empty space nudging the photons forward. The photon simply is a self-sustaining ripple, and the electromagnetic field allows exactly one propagation speed for that specific kind of ripple. So the ripple moves at that speed, not because something forces it to, but because that is the only mode of existence available to it. To picture how this self-sustaining process actually survives the cold void, imagine two invisible fields, an electric field and a magnetic field, coexisting in the exact same region of space. They sit at right angles to each other, both pointing perfectly perpendicular to the direction the light is going to travel. At this exact instant, the electric field is at its peak strength, pointing upward. The magnetic field is at its peak strength, pointing sideways. But these fields are not static monuments. They are highly dynamic, oscillating entities. And critically, they are oscillating in perfect, unbreakable synchronization. As time advances by an unfathomably tiny fraction of a second, the electric field begins to weaken. It drops from its peak upward value, falls back down towards zero, and then reverses to point downward. As it performs this motion, it is actively a changing electric field. And according to the unbreakable laws written down by Maxwell, a changing electric field automatically and instantaneously produces a magnetic field. The magnitude of the newly produced magnetic field is directly proportional to how fast the electric field is changing. So, while the electric field is rapidly shifting, a strong magnetic field is actively being produced. But the entire configuration is a wave, meaning the magnetic field is also simultaneously changing. As the magnetic field weakens from its own peak, it actively produces an electric field. As it drops, it generates exactly the electric field needed to keep the pattern alive. The profound magic of the universe lies in the balance of this interaction, the two coupling strengths. How much a changing electric field produces a magnetic field, and how much a changing magnetic field produces an electric field, are precisely tuned so that this loop perfectly closes on itself. The changes in one field are exactly, flawlessly what the other field needs to keep oscillating, and vice versa. The wave is entirely self-supporting. It carries itself forward through the absolute nothingness of the void because at every single point along its path, the pattern of changing fields is precisely calibrated to regenerate itself an instant later, a little further along the trajectory. This perfectly balanced dance is exactly why the wave has a specific, unyielding speed. If it tried to move any faster or any slower, the delicate timing of the regeneration would instantly fall out of synchronization. The changing electric field would produce a magnetic field that no longer matched what the overall wave required. The changing magnetic field would produce an electric field that no longer fit the geometry of the disturbance. The self-sustaining pattern would instantly tear itself apart and dissolve into nothingness. Only at one specific, mathematically locked speed does the whole intricate dance actually work. That single speed is set forever by the two coupling constants of the electromagnetic field, and that mathematically mandated speed is what we call the vacuum speed of light. It is not a speed the wave chose. It is the only speed the mathematics of the cosmos allows to exist. We are forced to abandon the comfortable illusions of our macroscopic world. The void is not a mechanical ocean waiting to be disturbed. It is a canvas of fields, a reality where information survives the darkness, not by riding on a physical substance, but by engaging in a relentless, perfectly balanced act of self-creation. The photon crossing the universe is a phantom that constantly pulls itself into existence, step by step, bound forever to a speed that is written not in the stars, but in the deepest, invisible architecture of the field itself. The realization that the luminiferous ether did not exist plunged the scientific community into a silent, conceptual crisis. It exposed an unbridgeable fracture between two monumentally successful pillars of human thought, the classical mechanics of Isaac Newton and the electrodynamics of James Clerk Maxwell. To Newton, and indeed to the entire lineage of physics that followed him, space and time were the absolute, immutable scaffolding of the cosmos. Space was an empty, infinite container within which matter moved, and time was a relentless, universal clock that ticked at an identical rate for everyone, everywhere, regardless of their state of motion. Within this Newtonian universe, velocities were fluid and additive. If you ran forward inside a moving train, your speed relative to the ground was simply the speed of the train plus the speed of your stride. It was a physics of common sense, perfectly intuitive, and entirely reliable for mapping the behavior of planets, cannonballs, and rivers. But Maxwell's electrodynamics whispered a completely different, irreconcilable truth. His equations demonstrated that light was a self-sustaining ripple in the electromagnetic field, and they predicted that this ripple propagated at one specific, mathematically locked velocity through the vacuum. Crucially, Maxwell's equations did not include any reference to a source or an observer. They simply stated that the speed of light was a fixed constant of nature, determined entirely by the fundamental properties of empty space. This created an intellectual paradox that threatened to tear physics apart. If Newton was right, the speed of light must change depending on how fast an observer is moving relative to the source. If you were to chase a beam of light, you should see it slow down relative to your own trajectory. But if Maxwell was right, the speed of light was independent of the observer, a stubborn, invariant value written into the laws of nature. For decades, physicists assumed that Maxwell's equations must only apply to a preferred frame of rest, the phantom ether, and that moving through this medium would reveal the true, variable nature of light's speed. But the experiments refused to cooperate. The ether wind could not be found, leaving the scientific world staring into a profound, unexplained silence. In the year 1905, a young clerk working in the patent office in Bern, Switzerland, looked at this conceptual fracture not as a problem to be patched with desperate, ad hoc hypotheses, but as an open doorway into a deeper layer of reality. Albert Einstein did not construct new, elaborate experiments, nor did he derive complex new mathematics. Instead, He chose to perform an act of supreme intellectual honesty. He decided to take the existing laws of physics completely and unflinchingly seriously. Einstein looked at the two conflicting principles. Galileo's ancient principle of relativity, which stated that the laws of physics must appear identical to every observer moving at a constant, steady velocity, and Maxwell's assertion that the speed of light in a vacuum is a constant law of nature. And he asked an extraordinary question. What if both of these statements are simultaneously absolutely true? The implications of this simple unification were radical and deeply disruptive to human intuition. If the laws of physics are the same for all uniformly moving observers, and if the speed of light is a fundamental law of physics, then it follows with absolute, inescapable logic that the speed of light must look identical to every single observer, completely regardless of how fast they are chasing it or running away from it. Let the full, unsettling weight of this statement settle into your consciousness. Imagine you are standing perfectly still on an open plain and a photon flies past you. You activate your instruments, measure its velocity, and find that it is traveling at the classic, universal value of nearly 300,000 kilometers per second. Now, imagine a second observer sitting inside a hyper-advanced spacecraft, racing along in the exact same direction as the photon at half the speed of light. Everyday common sense, the legacy of our biological evolution and Newtonian physics, dictates that this spacecraft pilot should look out their window and see the photon pulling away from them at only half its original velocity. They are chasing it, after all. They have closed the gap by half. But Einstein revealed that the universe does not operate on common sense. When the pilot activates their own instruments to measure that exact same photon, they do not register a diminished speed. They measure the photon moving at the full, unyielding vacuum speed of light. It pulls away from them at exactly the same velocity as it pulled away from you. The arithmetic of addition and subtraction that governs every other moving thing in our daily lives completely collapses when applied to light. Imagine a third observer running in the opposite direction, meeting the photon head-on at an immense velocity. They do not measure a faster photon. They too register the exact same invariant number, not a meter per second faster, and not a meter per second slower. The photon refuses to be overtaken, and it refuses to be hurried. It maintains its precise, mathematical relationship with every observer in the cosmos, acting as a stubborn, unmoving anchor in a universe where everything else is adrift. Einstein's invariance was not a temporary theory or a clever shortcut. It was a profound declaration that the speed of light is the one absolute truth that every perspective in the universe must respect. But this absolute invariance triggers an immediate, logical crisis. Speed is not a primary, isolated property of nature. Speed is a relationship. It is defined strictly as the physical distance traveled divided by the duration of time elapsed. If every observer, moving at vastly different velocities, must always compute the exact same numerical value for the speed of light, then the components of that calculation cannot remain fixed. If the answer to the division must always be the same, then the numbers we use for distance and the numbers we use for time must change depending on who is doing the measuring. To preserve the sacred, unyielding constancy of the speed of light, the universe is forced to perform a radical, almost terrifying act of geometric gymnastics. It must surrender the absolute permanence of space and time themselves. This is the exact point where our comfortable, classical reality dissolves into the flexible landscape of relativity. Because the speed of light is invariant, space and time cannot be what we thought they were. They can no longer be treated as an inert, rigid backdrop that remains the same for everyone. Instead, they must become fluid, dynamic, and profoundly responsive to motion. They must bend, stretch, twist, and contract in a perfectly coordinated mathematical choreography specifically designed to ensure that whenever any observer measures the speed of light, the result is always the same invariant number. The first and most existentially chilling consequence of this choreography is the phenomenon of time dilation. When an observer moves relative to you at an immense velocity, approaching the speed of light, time itself begins to pass differently for them. This is not an optical illusion, a psychological trick of perception, or a mechanical defect caused by the stress of high-speed travel affecting the internal gears of a clock. It is a fundamental, coordinate reality of the universe. Time itself literally slows down for the moving observer from your perspective. The steady, invisible ticking that carries events forward from past to future stretches out, expanding its intervals. If you could watch their heartbeat, the unwinding of their DNA, or the rhythmic swing of a pendulum inside their cabin, you would see everything operating in a deep, slow-motion crawl. Yet, from their own perspective inside the spacecraft, everything feels perfectly, flawlessly normal. Because their brain, their thoughts, and their local environment are all integrated into that same slowed coordinate of time. It is only when their perspective is compared to yours that the fracture in time becomes real. Simultaneously, as time stretches, space itself must compress along the direction of motion, a phenomenon known as length contraction. When an object races past you at a significant fraction of the speed of light, the physical distances within that object shrink from your perspective. A spacecraft that measures 100 meters long while sitting quietly on a launch pad will physically contract, appearing as a shortened, squashed version of itself as it hurtles through deep space. And once again, this is not a visual distortion caused by the time it takes light to reach your eyes. It is a true, physical alteration of space itself. To the moving pilot, their ship hasn't shrunk at all. Instead, they look out their viewport and see that the entire universe ahead of them has compressed, shortening the physical distance between the stars. Space and time are no longer independent, rigid containers. They are flexible, coordinate realities that trade places with one another, bending and stretching symmetrically to maintain the unyielding anchor of light's constant speed. For a few brief years after Einstein's 1905 paper, this fluid reality was viewed by many as a strange, almost miraculous set of independent rules. A collection of separate algebraic formulas that somehow kept the laws of electromagnetism in line. But in 1908, a brilliant mathematician named Hermann Minkowski looked deeply at the revolutionary framework his former student had constructed, and he realized that it held a profound, unified geometric secret. Minkowski delivered a famous, historic lecture in which he declared that from that moment on, space by itself and time by itself were doomed to fade away into mere shadows, and that only a kind of union of the two would preserve an independent reality. Minkowski swept away the separate, fluid concepts of stretching time and shrinking space by revealing that they were merely different viewpoints of a single, unified, four-dimensional grid, spacetime. Imagine looking at a physical three-dimensional object like a long wooden ruler. If you hold the ruler directly in front of your eyes, you see its full, true length. But if you slowly rotate the ruler away from you, its apparent length along your horizontal field of view begins to shorten. The ruler hasn't actually shrunk. Its length has simply been projected differently across your dimensions of perception because you altered the angle of your perspective. Minkowski revealed that time dilation and length contraction are precisely this kind of geometric projection, occurring within a four-dimensional arena. Every event in the cosmos, everything that happens anywhere, at any precise location, and at any fleeting moment, is a single, stable point within this four-dimensional fabric of space-time. When you accelerate and move relative to another person, you are not mechanically changing the universe. You are simply rotating your perspective within this four-dimensional grid. Your movement changes the angle at which you slice through space-time, what you call a pure distance in space. A stationary observer calls a mixture of distance and time. What they measure as a duration of time, you experience as a crossing of space. The adjustments in clocks and the compressions of rulers are just the cosmic shadows cast upon our limited, separate dimensions as we change our orientation within a unified, four-dimensional reality. And it is within this grand, four-dimensional geometry that the true nature of the speed of light is finally unmasked. This realization completely changes the nature of the question we are asking. The speed of light is not really a property of light at all. It has nothing to do with the brightness of a flame, the energy of an explosion, or the behavior of a photon. The speed of light is the universal conversion factor built directly into the geometric fabric of space-time. It is the cosmic constant that dictates exactly how much space corresponds to how much time within the architecture of reality. To understand what a conversion factor means in geometry, think of how we measure distances on a map. If you travel 3 miles north and 4 miles east, you can calculate your total distance using a standard geometric formula, because north and east are measured in the exact same units, miles. But imagine a strange world where north is measured strictly in miles and east is measured exclusively in meters. If you wanted to find the true, unified distance between 2 points on that map, your standard geometric formula would fail completely until you introduced a precise conversion factor, a specific number that translates meters into miles, allowing the two separate concepts to be unified into a single, coherent calculation dot. This is exactly what the speed of light does for our universe. It is the fundamental number that translates time into space, and space into time, allowing them to be seamlessly woven together into the unified four-dimensional fabric of space-time. It is the geometric constant that tells the cosmos how many meters of space are exactly equivalent to 1 second of time. When we express the speed of light as nearly 300,000 kilometers per second, we are not reporting a velocity that a particle happens to achieve. We are reading the cosmic code that declares 1 second of time is geometrically identical to 300,000 kilometers of space. Light moves at this speed simply because it is a massless entity, entirely unburdened by material anchors, and it has no choice but to travel along the natural, unvarnished pathways of this unified geometry. This is the deep, elegant reason why the speed of light sneaks into equations across all of physics that appear to have absolutely nothing to do with light, illumination, or optics. It is why it appears in Einstein's most famous equation, dictating that the resting energy of a stationary chunk of matter is precisely equal to its mass multiplied by the speed of light squared. It is why it governs the laws of nuclear physics, the decay of radioactive particles, and the intense gravitational warping around a black hole. The speed of light is present in those equations because those equations are describing physical processes unfolding within space-time, and the speed of light is the structural constant that defines the very metric of that space-time. It calibrates the light cone, mapping the rigid boundaries of causality, dictating exactly which events in the vast history of the cosmos are allowed to influence the present, and which events are forever isolated across the space-like voids of the unreachable universe. We are left with a profound, grounding philosophical reflection on the nature of our place within this unified geometry. We live out our brief, fragile lives heavy with mass, deeply convinced that our separate, biological perceptions of minutes and miles represent the definitive, unchanging blueprint of the cosmos. We look out at the cold, silent voids of deep space, and we feel an overwhelming sense of isolation, measuring the light years that separate us from the stars and mourning the passage of centuries that keeps us marooned in time. But the invariance of light pulls back the curtain on this superficial, classical interpretation of existence. It reveals that the separation we experience is a product of our perspective, a localized shadow cast by our movement through a four-dimensional arena. Space and time are not cold, dead, indifferent containers holding us separate from the cosmos. They are a single, living tapestry, woven together by a cosmic conversion factor that ensures absolute harmony across every viewpoint in existence. The speed of light is the signature of that harmony, a constant reminder written into the geometry of reality that beneath the shifting, fluid illusions of here and there, past and future, there exists a unified, immutable architecture that holds the entire cosmos together as a singular, completely coherent whole. We are not isolated observers drifting through an empty grid. We are embedded nodes within an unyielding geometric conversation where the very ticking of our hearts and the distances between the galaxies are balanced forever by the constant, silent speed of the messenger that weaves the void from the inside out. We spend our lives surrounded by things that can always be pushed just a little bit harder. Our everyday intuition tells us that velocity is simply a matter of effort and fuel. If you want a car to go faster, you build a larger engine. If you want a rocket to reach the distant planets in less time, you engineer a more violent chemical reaction to drive it through the void. In the macroscopic world of our daily experience, the relationship between energy and speed feels perfectly linear and open-ended. It feels as though, if we simply possessed an infinite reserve of power and boundless technological ingenuity, we could accelerate an object to any speed we desired, crossing the vast, silent gulfs of the cosmos as quickly as our imaginations might demand. But the universe does not run on human intuition. It runs on a deeply rigid, unyielding geometry, and this geometry imposes a hard, absolute mathematical veto on our dreams of limitless acceleration. The question is no longer why light moves so fast, or what invisible hand is pushing it forward through the vacuum. Once we understand that the invariant speed is a fundamental parameter of spacetime itself, a number written directly into the geometric structure of reality, the question entirely changes. The question becomes, given a spacetime with this invariant speed permanently built into it, what kinds of objects can move at that speed and what kinds cannot? The answer to that profound question is where the concept of mass enters the story. And it is here that we discover the deepest reason why photons travel at this cosmic limit while everything else is forever trapped below it. Every physical object you have ever touched, every planet you have ever seen, and every biological cell in your own body possesses a fundamental property called rest mass. Rest mass is the mass an object has when it is completely stationary, not moving relative to its environment. A standard baseball has a rest mass of about 145 grams. A single, microscopic electron has a rest mass roughly 1 billion times less than a single gram. That is a number extraordinarily small, but crucially, demonstrably, it is not zero. Any object with a non-zero rest mass, no matter how vanishingly small it might be, possesses a very special property in the architecture of spacetime. It has a rest frame. There is a mathematically valid way of setting up a reference frame in which the object is simply not moving. You could, in principle, run alongside the object at exactly its own velocity and look over to see it sitting perfectly still. This simple fact, the possession of rest mass, triggers the first great, unyielding rule of relativistic geometry. In the four-dimensional structure of spacetime, an object with rest mass traces out a continuous, unbroken path. Physicists call this path a world line, which is essentially the entire history of the object, plotted moment by moment and position by position through the universe. And the geometry of spacetime enforces a strict, unbreakable rule on the shape of that world line. It must always be what physicists call time-like. Roughly speaking, this means the object must always move through time faster than it moves through physical space. But what actually happens if we try to force a massive object to break this rule? What happens if we put an object inside an incredibly powerful machine and attempt to accelerate it to the invariant speed of light? As a massive object speeds up, its kinetic energy increases. In classical physics, this is a familiar, predictable quadratic curve. But in the reality of relativity, kinetic energy increases in a deeply peculiar way as the object's speed begins to approach the invariant speed of light. The energy requirement does not rise at a steady pace. It increases faster and faster, curving upward without bound. Nudging an object that is already moving close to the invariant speed, even a hair closer, requires an enormous, staggering amount of energy. Pushing it closer still requires vastly more than that. As the object's speed creeps closer and closer to the invariant speed, the amount of energy required to nudge it any faster grows without any limit whatsoever. To actually bridge the final microscopic gap, to reach the invariant speed, would require an injection of infinite energy. We are not speaking of a lot of energy, or an unimaginable amount of energy. The mathematics demand an actually infinite amount of energy. And the universe, for all its vastness and roaring stellar furnaces, does not contain infinite energy. Therefore, no object with rest mass can ever, under any circumstances, reach the invariant speed. It can get closer and closer, pushed arbitrarily close by massive accelerators, but it can never actually arrive. Massive objects are permanently locked below the invariant speed by the very structure of relativity, their world lines condemned to remain forever time-like. They can move as fast as they like up to the limit, but they are forbidden from ever existing at the limit. Now, consider the complete inverse of this reality. Consider what happens for an object that possesses absolutely no rest mass at all. This is the ethereal domain where photons live. If an object has exactly zero rest mass, the very same set of relativistic equations that ruthlessly forbids massive objects from reaching the invariant speed does something completely different. The equations do not forbid a massless object from moving at the invariant speed. They absolutely require it. A massless object cannot move at any speed less than the invariant speed. It cannot sit still in a laboratory. It cannot travel slowly through the vacuum, and it cannot pause. The only speed mathematically available to it is the invariant speed of light. The reason for this lies in the intricate balance of the universe's ledgers. The relationship between energy, momentum, and rest mass in relativity works out in such a way that a massless object possessing any energy at all must be moving at the invariant speed. The equations simply do not allow for anything else. If a photon possessed zero energy, it would not exist at all. It would be mathematically nothing. As soon as it exists, the instant it flares into being, its energy is non-zero. And the only possible way for a massless object with non-zero energy to satisfy the strict relativistic equations of the cosmos is for it to be moving at the invariant speed. Not almost, not approximately, but exactly. This is the profound reason why photons can never sit still. It is not because some invisible force is preventing them from resting, but because the geometry of space-time, combined with the sheer fact of masslessness, leaves absolutely no other option. A photon is required by the mathematics of the universe to move at the invariant speed. It has no other mode of existence. This completely erases the intuitive idea of acceleration. A photon does not need to accelerate up to its speed. It does not start out slow and then rapidly speed up. There is no phase during which it exists but is not yet traveling at the invariant speed. the instant the photon exists, the instant an atom finishes emitting it, or a nuclear reaction produces it, or a particle accelerator creates it. It is already moving at the invariant speed, because that is the only speed a massless object is allowed to have. There is no ramp, no engine, and no push. There is just the sudden, perfect arrival of a massless quantum of the electromagnetic field, existing in the only way it can possibly exist, moving at the invariant speed built into the fabric of spacetime. This brings us to a geometric structure that governs the entire flow of reality. If massive things are forever trapped below this speed, and massless things are forever locked exactly at it, then this invariant speed acts as a cosmic scaffolding. Physicists call this structure the light cone, and it deserves a much closer look because it is one of the most important geometric structures in all of physics. It is the geometric object that ruthlessly enforces the speed limit of the universe. Imagine standing in the dark. Imagine a single event, a single, fleeting point in space-time at a specific place and a specific moment. From that precise event, a flash of light can be emitted in every direction simultaneously. As time moves forward, that light spreads outward. In our familiar, three-dimensional space, it forms an ever-expanding sphere of illumination. But in the four-dimensional picture of space-time, where time is a physical axis, the surface of that expanding sphere traces out the shape of a cone. This is the light cone of that specific event. The cone is divided into two distinct halves. The future light cone consists of all the events that could possibly receive a light signal sent from the original event. It contains every point in space-time that light emitted from that moment could theoretically reach. The past light cone consists of all the events that could have possibly sent a light signal to the original event. It contains every point in space-time whose light could have theoretically arrived at that exact moment. This geometry divides the entire universe into absolute categories of consequence. Anything sitting inside the future light cone is causally reachable from the original event. A signal traveling slower than light, anything moving on a time-like world line, can get there in time to affect it. Anything sitting inside the past light cone could have physically influenced the event. But anything sitting outside the light cone, anything that would require faster than light travel to reach or be reached by, is causally disconnected from the event entirely. No signal can cross that boundary. No influence, no matter how powerful, can reach across it. The light cone divides space-time at every single event into the reachable and the unreachable. The specific value of the invariant speed of light defines exactly where the boundary of this light cone lies. If the invariant speed was somehow larger, the cone would be wider, and more of space-time would be causally connected to the original event. If it was smaller, the cone would be narrower, isolating us further from the cosmos. The specific value of the invariant speed is what determines the geometry of causality itself. It tells the universe exactly how much of the future is allowed to be influenced by the present, and exactly how much of the past could have possibly influenced the present. Every event in the universe possesses its own light cone, and every event's light cone has the exact same angular opening, simply because the invariant speed is the same everywhere in the dark. The rule that no signal, no object, and no influence of any kind can travel faster than the invariant speed is not just a quirky rule for light, it is the absolute rule for causality itself. To recognize that this is not merely an abstract mathematical fantasy, we only have to look at the atmosphere directly above our heads. The invariance of this speed, and the bizarre geometric stretching of time and space it demands, has been tested to a precision that borders on the absurd. Consider the frantic, doomed lives of muons. Muons are subatomic particles remarkably similar to electrons, but roughly 200 times heavier, and they are violently unstable. They decay into other, lighter particles after a remarkably short lifetime. In a laboratory where a muon is at rest, it lives for only about 2 microseconds on average, 2/millionths of a single second, before winking out of existence. High in the Earth's upper atmosphere, roughly 15 kilometers above the surface. Cosmic rays from deep space continually crash into air molecules, producing these heavy, unstable muons. If we rely on classical Newtonian physics, the math paints a grim picture for these particles. Even if a muon were traveling at nearly the invariant speed of light, lasting only 2 microseconds would mean it could cover only about 600 meters before decaying and vanishing. Created 15 kilometers up, without the strange rules of relativity, essentially none of these muons should ever reach the ground. The numbers simply do not come close to working out. And yet, muons produced in the high, freezing upper atmosphere are detected at ground level in enormous, undeniable numbers. How is this possible? Because these particles are traveling downward at nearly the invariant speed of light. And at speeds approaching that absolute cosmic limit, time dilation becomes enormous. From our stationary reference frame on the surface of the Earth, watching the muons streak downward, their internal clocks are ticking much more slowly than clocks at rest. Their brief 2 microsecond lifetime, from our perspective, is stretched into a much longer duration, long enough for them to easily reach the ground before decaying. From the muon's own perspective, plummeting toward the Earth, they still live only 2 microseconds. But from that high-speed perspective, the atmosphere rushing up to meet them is severely contracted along the direction of motion, and the physical distance to the ground is much, much shorter. Either way, whether we calculate it through the stretching of time or the shrinking of space, the mathematics flawlessly works out, and the muons arrive, every single time, in numbers exactly consistent with the geometric predictions of relativity. We do not even need to look to the upper atmosphere or massive particle accelerators to find this geometry at work. It is operating quietly in your pocket. If you carry a modern smartphone with GPS capabilities, you are relying on these exact relativistic corrections at every single moment of your day. The satellites that comprise the global positioning system orbit the Earth at high speeds, carrying extraordinarily precise atomic clocks on board. Because they are moving rapidly relative to the surface of the Earth, the geometry of spacetime dictates that these clocks run slightly differently from identical clocks resting on the ground. If the effects predicted by relativity, the stretching of time required to preserve the invariant speed of light, were not meticulously included in the GPS calculations, positional errors would rapidly accumulate at a terrifying rate of roughly 10 kilometers per day. Within a single week of uncorrected operation, your phone would place you in the wrong city, nowhere near your actual physical position. The fact that GPS works, guiding us smoothly to within a few meters of our destinations, is a daily, hourly, minute-by-minute confirmation that time and space behave exactly as relativity says they do, and that the invariant speed of light is exactly the unyielding cosmic anchor it claims to be. Every test agrees, and every experiment confirms it. The invariant speed is real, it is universal, and it is stitched into the geometry of the universe at a level far too deep to be dislodged by any measurement anyone has ever devised. This leaves us with a quiet, grounding realization about our own existence. We are creatures of heavy matter. We are built of protons, neutrons, and electrons, all of which carry the stubborn burden of rest mass. Because of this, we are prisoners of inertia, moving slowly through the world, bound by the heavy ticking of clocks, forever trapped inside the interior of the light cone. We can look out at the universe, but we can only ever interact with a tiny, delayed fraction of it, separated from the deep cosmos by the rigid walls of causality. Yet, this geometric prison is also the very thing that makes a coherent reality possible. The invariant speed of light is the scaffolding of cause and effect. It is the rule that ensures the universe does not happen all at once, preventing causes from bleeding backward into effects, and stopping the cosmos from dissolving into a chaotic, paradoxical blur. It forces the universe to unfold in a logical, chronological sequence. We may be heavy, slow, and restricted, forever watching the massless photons race effortlessly along the boundaries of existence. But it is exactly because we are massive, And exactly because this speed limit exists, that we have the time to exist, to evolve, and to look up at the dark night sky, finally understanding the invisible lines of geometry that hold the silence together. We have spent our time together, dismantling the mechanical myths that have held our understanding of reality captive for centuries. We have looked deep into the heart of the electromagnetic field, peeled back the geometric scaffolding of space-time, and confronted the unyielding, invariant nature of the speed of causality itself. Yet, there remains one final, stubborn loose thread. A phenomenon so common, so central to our daily experience, that it seems to contradict everything we have built. We have stated, repeatedly and emphatically, that every photon in the vacuum of space must move at the exact same invariant speed. And yet, the moment you place a simple piece of glass, a crystal of diamond, or a bowl of water in the path of that light, it appears to slow down, sometimes dramatically. If the speed of light is truly stitched into the immutable fabric of space-time, how can a chunk of matter, a mere collection of atoms, force it to deviate? The resolution of this mystery is one of the most beautiful and frequently misunderstood chapters in the history of optical physics. It hinges on the fundamental realization that a piece of glass is not an empty, passive void. It is a dense, intricate lattice of trillions upon trillions of atoms, every one of which is populated by electrons that are exquisitely sensitive to the electromagnetic field. When a photon enters a material like water or glass, it does not stop being a photon, and it does not slow down as an entity between the atoms. The electromagnetic field still permits only one propagation speed for its ripples, and that speed remains the same invariant vacuum constant we have explored throughout our journey. What actually occurs is a collective, macroscopic dance of immense complexity. As the electromagnetic wave ripples through the material, it exerts a tiny, rhythmic force on the electrons bound within the atoms. It wiggles them, forcing them into a state of rapid oscillation. Because these electrons are charged particles, their movement creates an accelerating charge, and according to the laws of electromagnetism, accelerating charges must produce their own electromagnetic waves. So, each atom in the material, in response to the incoming light, emits a secondary, re-radiated wave of its own. This new wave ripples outward and adds itself to the original incoming wave. When you sum the contributions of the original incoming wave and the millions of tiny, re-radiated waves from every atom in the lattice, the result is a composite, effective wave that appears to move through the bulk of the material at a speed significantly lower than the original vacuum velocity. The atoms are not slowing the light down mechanically, in the way a person might slow down while walking through water. They are contributing their own secondary waves that, when combined with the original, produce a total composite wave whose crests and troughs advance more sluggishly through the material. This is what we call the phase velocity of light in a medium. It is a real, measurable quantity, but it is an emergent property of the collective interaction, not a fundamental property of the photon itself. Between those interactions with atoms, in the tiny gaps of vacuum, the photon is still traveling at the full, invariant vacuum speed. The slowing is an accumulation of delays, a summary of a complicated dance, not a change in the fundamental physics of the light ripple. This is also why the phenomenon of dispersion exists, splitting white light into the vibrant, beautiful colors of a rainbow when it passes through a glass prism. Different frequencies of light are wiggling the electrons in the glass at different rates, leading to different strengths of interaction and, consequently, different amounts of effective slowing. Blue light is slowed more intensely than red light, causing the colors to separate as they bend through the material. The invariant vacuum speed remains perfectly untouched throughout this process. What varies is only the behavior of the composite wave as it interacts with the physical structure of matter. This distinction matters because it clarifies the existential truth of our universe. The invariant speed is not merely the fastest speed light can go. It is the fundamental speed limit of causality within the geometry of spacetime itself. If we were to produce conditions using ultra-cold clouds of atoms, as physicists have done in laboratories, we could indeed slow a pulse of light to the speed of a bicyclist, or even bring it to a complete halt for a fraction of a second before releasing it to continue on its path. But at no point during any of those experiments is any individual photon moving at anything other than the invariant speed between the atoms. The invariant speed is the bedrock. Everything else, the slowing in glass, the refraction of a lens, the rainbow in a prism, is just the play of light against the structures of the material world. Having resolved this final mystery, we must also address the numerical baggage we have carried throughout this exploration. We have treated the number 299,792,458 meters per second as if it were a fundamental truth of the cosmos. But we must recognize that this number is, in a very real sense, a human invention. It is not the physical fact of the invariant speed that is human, but the specific numerical representation we attach to it, which depends entirely on the units we use to measure space and time. Today, the meter itself is defined by the International System of Units in terms of this speed. It is defined as the distance that light travels in a vacuum in exactly 1/299 millionth plus fraction of a second. So, this famous number is no longer a measured value. It is a definition, a human convention chosen for our own convenience to match older, historically grounded standards. The universe does not know what a meter is, and it does not know what a second is. It has an invariant speed, and we have chosen arbitrary units in which that speed happens to have the numerical value we record. If we had measured distance in miles or time in cycles of the moon, the number would look completely different, yet the physical reality would remain identical. Physicists who work on the deepest theories of relativity, quantum field theory, and cosmology often adopt units where the speed of light is set to exactly 1. In these unit-free systems, light does not race. It simply walks, covering 1 unit of distance per 1 unit of time. The idea of light being fast falls away, because it is simply traveling at the natural rate of the geometry it inhabits. By stripping away this numerical baggage, we reveal what is actually happening underneath. The invariant speed is not a speed at all in the everyday sense. It is the geometric conversion factor that turns time into space and space into time in the fabric of reality. Light does not choose this speed. Light does not earn it. Light does not accelerate up to it. Light simply is the kind of thing that lives on it. The photon is not a traveler that carries its own engine or a bullet launched from a gun. It is a ripple in a field that fills all of space, and its movement is a property of the field and the space-time it occupies. When we ask where light gets its speed, we are asking why the universe is constructed with this specific geometric limit, and why massless things are forced to move along it. The honest answer is that we do not know why the constants of nature take the values they do. We know the geometry is invariant. We know the speed is universal. We know that massless things must travel upon it. But as for why the universe is tuned to this specific geometric note, we have reached the frontier of what human physics can explain. There is a profound, grounding comfort in this realization. We are not lost in a universe of random, inexplicable speeds. We are participating in a reality that is fundamentally unified, where the distant stars and the light on your screen are both rippling through the exact same field, obeying the exact same geometric constraints. Light is fast, not because it is bright, and not because it is energetic, but because it is massless, and because the universe is built in such a way that anything massless has no other mode of existence than to race along the very lines of causality that hold our reality together. The next time you see a candle flickering in the dark, or catch the faint, ancient glow of the stars, remember that what you are witnessing is not just a particle in motion. You are witnessing the fundamental pulse of the cosmos. You are seeing the invariant geometry of space-time made visible, a ripple in the field that connects you to the farthest reaches of time and space, moving at the only speed the universe allows. We are the witnesses to this dance, temporary patterns of mass in a universe defined by the speed of light, finding our own meaning within the rigid, elegant lines of the light cone. It is a vast, mysterious, and deeply structured home we inhabit, and we are only just beginning to learn how to read its language. Good night, and see you in the next video.